You did it together?
Yeah, for the test.
For the test?
No, like preparation.
But you work together?
Yeah, we work
yeah.
together.
Why, what was your topic?
Acid and base.
Oh, okay, alright.
Do you know what's the percentage on the sheet about if you talk for 2 months?
Oh my god, this guy can talk. It's 20 minutes.
20 minutes?
Like we could have started the class at 9:50.
No, I thought it was 20 minutes. Like
20 minutes on top.
20 minutes? Yeah, you might lose some marks for that.
Without.
But I didn't get any slides actually.
What's that?
I just spoke from myself. I didn't get it.
Yeah, that's not a good thing.
Yeah.
That's not a good thing.
I started sleeping.
Even you spoke too much.
Yeah, I do, but I didn't reach 20 minutes.
Nah.
And it was interesting. Funny.
No.
Funny?
Yeah, this is my first life, Cook's Law. You know Captain Cook?
You didn't, did you?
But you didn't make a joke on that. You just passed by it.
Oh, you laughed at it.
No.
What?
That's Stephen bad.
He just, he even didn't say, oh, it's that. He didn't say anything. He just pressed the next one, next.
He let the picture do the
Yeah.
talking. Yeah, okay. Fine.
Like 2 seconds.
Fine. Let's continue. Do you mind getting the light there, KJ? Alright, so if I can just borrow that for a second. Can you still see it with the light on though?
Yes.
Put the light back on, let's just have a look.
No.
No?
I can actually, because this is just.
It's like
Because it's just like.
Bird number four.
Hang on, let's just have a look. How do... no, you need the light off. Yeah, turn the light off then, so... Right, okay.
You can put the grapes if you want, if you can't, because they cannot say.
Pull it up a little bit. Oh no, wait, hang on. It's broken. It can only go down, not up. No, forget about it. Alright. Okay, so what we're having a look at is standard normal distribution. Okay, standard normal. Right, I have my spreadsheet open. Okay, so remember last time, previously on maths class, we saw a histogram, but a very special type of histogram. What does the area represent on this histogram? Yeah, proportion, percentage. So the total proportion is 100%, or 1 as a number, okay? Now, in fact, in statistics, having a histogram, and then let me open up the... Yeah, in statistics, having this type of histogram where it's what? This is a great histogram. I don't know what you're laughing at. Yeah. Having a histogram that's this shape, what's called a bell shape, where it curves up and then curves back down like this. This is called a standard normal, or a bell histogram. Standard normal distribution, or in kind of simple English we call it a bell curve. Yeah, you got that bit? Bell curve. So, for this particular bell curve, there is actually a table book that tells you the proportions. you look up the number in the table book, and the number in the table book is the proportion to the left. That's smaller than this value. And the other thing about this standard normal bell curve is that it's always drawn in the table book as having a mean centered at 0, and it's also drawn with a standard deviation of 1. So yeah, this is 0
Always.
in the table book, and the standard deviation is 1. And in fact, there's a symbol as well. We can often call this, if this is the x-axis, or the z-axis, or whatever you want. If I write x, this symbol, n0, 1, what that means is that x falls on a bell curve with average mean of 0 and standard deviation of 1. So this number here is around about -1, and this number here is about -2, and this number here is 1, and this number here is 2. Standard deviation 1, yeah. Let me give you some data to show you that makes this type of histogram shape. Let me actually, I think I had Excel open, but I want a different program open actually to make a better histogram.
I found out Linux is not operating system.
Not really.
Yeah, technically.
It's the Linux is the kernel,
Yeah.
and what's the operating system is open. What's it called? Free. The GNU project, isn't it?
Yeah.
General
Free soft programs.
General GNU General.
The GNU is not Linux.
No, it's the free operating system. Linux is just the kernel.
Yeah.
Yeah. What's the project called that has all the free programs? I can't remember. Anyways, I want to show you a histogram like this. Oh, come on. I don't need Excel. Yeah, maybe. Right. So what do the numbers look like that have this kind of histogram shape to it? This nice bell curve shape. Well, let me generate some numbers that follow this histogram pattern.
From house view.
Yeah. So we'll call it data. And what is it? Let's make 10 numbers. Oh, come on. Everything's going slow today. Slow day.
After this we have a 2 hours break.
There we go. Right. So here are 10 numbers. If you put these 10 numbers in a histogram, the shape it will make is that nice bell curve shape. I'm going to make the histogram in the program to show you. Histogram of the data.
Is there a sequence or something like that?
Is there what? No, don't worry about the program.
No, the numbers.
Oh no, the 10 random numbers.
Do they have a specific gap or difference?
No, just have a look at the histogram now. Sorry. Right, so, well, 10 numbers is not quite enough. I'm going to make 100 numbers and put them in a histogram. So not quite perfect, but you see that you have this nice bell shape to it? So here are my 100 numbers. Look up, KJ. Are you on your phone? Put your phone away. Here are my 100 numbers. If you put these in a histogram, it makes this histogram. So for example, how many of my numbers are between, let's say, 0 and 1? Well, how do we get that? It's the area, isn't it? So how big is the base here? 1. Now, there's 2 rectangles, so I'll just estimate it as 0.3. So I'm going to say this area here, can you see it in the cursor? Is about 30%. So 30% of these numbers are between 0 and 1. What should the total area be? 1. So 100% of numbers are between about -3 and about 3. Can you see any number which is less than -3? Well, maybe about this one here.
What is it?
-3.12. Yeah. Now what happens if you think I add more numbers? So if I make 1,000 numbers and draw the histogram, not necessarily wider, but you see now it has more of a nice bell shape to it. What about if I make 10,000? Do you see how the histogram is becoming more of a nice bell curve to it? 100,000. It's getting this nice bell shape. And you can see that -4 to 4 is now representing.
Exactly.
It looks like what?
Burj
Tallest
Khalifa.
building, Burj Khalifa.
I don't think that's what they were going for with the design.
Maybe the idea came up like this.
So if I have, how many have I got now? 1 million. And so on, and so on. So you can make this very, very nice, smooth histogram. Okay? Right, so, again, what goes on the y-axis here? The density. Yeah. So let me just draw that in. So here on the y-axis is the density. And for example, here if I shade in 0 to 1, to me that looks like, if I remember correctly, I think this is like what did we say in the program? About 30 something percent, wasn't it? So it's about 30%, for example, here. Now, in the table book, which I'll show you in a moment, when you look up 1, what you get is the area to the left of 1, which is this total here. Now what's really nice is that it's symmetric, and if the total must be 1, how big is the area here to the left? 50%. So if I look up 1 in the table book, what should I get? What is this area here, do you think? 80%, yeah. So if I look up the table for 1, the table will give me about 0.8, which is 80%. So what you're saying is that 80% of this data is less than 1. Yeah? Now let me show you this table book since I keep talking about it. Yeah.
Like an app.
No. You'll have it in the formula book, but I'll show you it on the screen here. Okay. So, we have enough internet juice? I got internet juice, don't worry. Right, standard, normal, table. So often I go to images because it's usually scanned in from a formula book. So this is exactly the type of thing you'll get in the exam. Well, no, not quite. The one in the exam gives you all the area to the left, not just the shaded piece here. I think, yeah, it's more like this one for the exam. So let's zoom in on this old school one. So for example, the Z is 1. So what you do is you go down to 1, and if you need decimal places, you can go across to get the second decimal place. So 1.0, what do we get? pretty close to what I was guessing. 84.8413, 84%. Close. Now, if I put in a number like 2, what should I get? Yeah, it won't quite be 100, but we think it should be near 100. So if I look down at 2, I get 97%. Yeah? If I go to 3, I should be even closer to 100. So 3 is 99.87%. In my picture?
Yeah.
That's just because it's my picture. It continues out.
Oh.
Yeah, it flattens out. So if I go as far as 3.49, that's 99.98%. So really, there's not much point in going past 4, because there's very little after 4 on each side. So for example now, can you see these numbers? Yeah, well, just about maybe. So for example, if I look up 1.21, there's 1.2, and there's 1.21. Let me just double check if that's right. Number. Yeah, that's right. 88.69%. There's a special symbol. If you, sorry, my pen again. Yeah, you'll get that in the formula book. You don't need to memorize it.
What type of wisdom?
Yeah, now you see, the next lesson is more useful where we have practical application. But right now, this lesson is about practice using the table book, really. So, my pen has decided to give up on me, like some of my students.
Even today we can.
Hold on.
Even today we can finish it for.
Oh yeah?
Yeah.
Come see me at 3 then, in the office. What was I talking about? Oh yeah, the symbol. Huh?
The second class is tutorial.
No, class today. So if you want to look up the table book, we use this symbol. So if I wrote this phi, 1.5, what that means is the area to the left of 1.5. That is the percentage of what? Percentage less than 1.5. Yes?
Mm-hmm.
And how do you get that? That's by using the table book at 1.5. So, yeah?
Then what's the use just answering by looking at the table? Yeah, that's it.
Well, really, we're practicing using this table because the next lesson will give us practical problems. But sometimes we don't want quite this. I'll give you another example. So 1.5 would be 93%. So 93% of this special standard normal data is less than 1.5. Now what about if I had asked a question like this? If I have my standard normal data, which makes this histogram shape, well you know what I mean. And suppose I want the area between 1 and 2. And I can only use the table book. Well, if you think about it, yeah, what do you think?
You can take 1 and 2 and minus 1.
Yeah, if you look up the value of 2, you get the area to the left of 2. And if you look up the value of 1, you get the area to the left of 1. So the answer, the proportion of numbers that are between 1 and 2, this is probability, proportion. Proportion that are between 1 and 2 would be the value 2 in the table book minus value for 1. That gives us this piece here. Yeah? So this is like our first real example. Let's look that up. So value for 2 is 0.99772.
for 2.
0.9772, and for 1 it's 0.8413. So what's that, please? Can someone just hit that in?
It's 0.1359.
0.1359.
1359.
So 13.6% of this data will be between 1 and 2. Okay, so we're getting the idea here for this. Yes? Yeah. Now what about this one? Can I go down a second? Yeah. What about if I asked you something like this? How much of the data will be more than 3?
100 minus 3.
Yeah, for this one, the probability that the data... Oh, by the way, I didn't say this, you might have noticed it, but this special data, we usually give it the letter Z to remind us that special data that's in the table book. Okay? So this Z data, what's the probability that this Z data will be more, a particular value will be more than 3? 1 minus...
Function.
Yeah, actually this...
What do you call
phi.
that? Yeah,
Phi, not work function. Yeah. 1 minus the work function of 3. That will equal 1 minus 0.9987, which will be 0.0013, which is, you know, it's not even 1%, it's 0.13 of a percent, tiny. Yeah? Okay, next one. Example. Okay, so here is minus 2 to minus 1. So how much of a chance do we have of being between these two?
One function of minus 1.
Yeah. Minus 2. Now, I should tell you though, the table book only starts at 0. No negative numbers.
So we can just take the value of 2 and just put the minus?
No.
Because it's exactly the same.
Well, give me that sentence again, but think carefully about what you're
It's
saying.
reflecting? Like
Yeah, reflected.
Yeah.
So this is actually the same as 1, 2, which is the same as this minus this, which we actually done earlier. It was 13.6%. Yeah? Okay, can I go down? Now, I'm going to give you one. I don't want you to use the table book. I just want you to write down what you would need to look up in the table book. So here's our histogram. And this is our density. And this is minus 1 and minus 2 and so on. So I would like the area from minus 2 to 1. So I want this area.
Do we have to like just use that like to make, because we can use any method to calculate that area?
What do
Not
you
like
mean?
it's plus minus, you know, like different.
Oh, how to break it up?
Yeah.
Oh, yeah. Yeah, you should get the same number.
Yeah.
Yeah, because I can think of, in my head, I can see at least 2 ways to break this up.
We can do the we can get the two value minus from 100 and then
Minus from 1.
yes, sorry, minus from 1 and then take the whole value of 1 and minus from that value.
Yeah, there's many ways. Have you got an answer? What did you go for the?
1 minus the phi 2.
Yeah, 1 minus phi 2.
Yes. Then phi 1 minus the answer.
Phi 1 minus the previous answer, which is 1 minus phi 2. That's what you were saying. So you went for phi 1 minus 1 minus phi 2. Very good. And that's what I would have gone for as well. So here your answer would be, let's see, phi 1 plus phi 2 minus 1, basically. I just opened the brackets. What's wrong, KJ? Yeah. Yeah. So let's look that up. Actually, you should have phi 1 already. What we've used that one. What's phi 1?
100.
No, phi 1.
Oh, sorry,
Did you not write it down?
90.
0.8413. And phi 2 is 0.9772 minus 1. So what's that, please? 977. Yeah, what's that, please?
It's 0.8202.
0. Yeah.
2.
Yeah.
02.
So 82%.
Yeah.
So 82% of standard normal distribution data is between -2 and 1. Yeah. Now, you can actually go backwards as well. So for example, if I wrote this with the inverse symbol here, what do you think that means?
The universal is 0.
Yeah, but what does that mean for
the
yeah.
minus 5 value.
No. Pi? No.
Pi.
Is it pi?
5.
Pi? Goodness. Yeah?
So on the
5.
graph is upside down.
No.
Phi 1 minus 0.7 value.
No.
1 over 0.
No. Oh goodness, no.
1 over, yeah.
I'll tell you. No, nothing like this. This here is Z, and it's the Z that makes an area of 0.75. It's going backwards. So here, when we use phi of Z, it gives us the area to the left of Z.
Yeah.
Here, when we use phi inverse a number, it gives us the Z that makes this area. It's exactly the opposite.
Oh, okay. So we need to find that number.
We need to find 0.75. So I can see 0.75 is, it's around about here. It's not, that's not an exact value. It's between here and here. Can you see?
Yeah.
So that's about 0.67 or 0.68. So for me, this would be about 0.675 is what I would say.
2.675?
No, 0.675. This value of Z will make an area of 75%. Yeah?
Mm-hmm.
So, I just want to go back to this program.
Goes up to how many?
The tail technically goes to infinity either way, but it becomes so small after 4, we ignore it. And then after 6, it's practically gone, because the area after 6 is, less than 1 over a million as a proportion. So forget about it after 6. Okay, let me just go back here and make 100 numbers again. So here I've simulated 100 normally distributed Zs. Actually, you know what, I will call it Z. Look up please, KJ. So here's my Z. KJ, please focus. Here's my Z numbers as an example. So, if I go back to, let's say, this one here. If I have 100 numbers, how many of them should be less than 0.675? 75%. See, I made it easy for you. So if I have 100 numbers, how many of those 100 numbers will be less than 0.675? 75. Very good, children. Right, so let's calculate how many numbers are less than, what did I say, 0.675. Wasn't it? I think I do it like this. No. Yeah. 81 numbers. Now, it's not going to be perfect because there's a random nature to this. Okay? If I increase the sample from 100 numbers to 1,000 numbers, I'll get more accurate. So if I have 1,000 numbers, how many should be less than 0.675? 750. So let's have a look. If I make 1,000 numbers, here are my 1,000 numbers. How many are less than 0.675? We want about 750. And this is much better now, 745. So it's pretty accurate. Yes, now what's your question?
In exam, if they are like this, in this way,
Yeah.
then if we just use the math and just take the percentage of 0.75, then it would be fine.
If you did what?
Like, like we just said, it's 75%.
Yeah.
Because we just took that 0.75 and take the percentage of that, right?
Yeah.
So if we do the same thing in exam, it would be fine.
Do what? What are your choices? 75% or 0.75?
No, like, for example, in this program, when you there was 100 numbers.
Yeah.
So if the program gave like something 80.
Yeah.
So if we just said that if it's a 100 number and 75%,
Yeah.
it would be fine.
I'm not sure your question. I understand everything except for the last sentence.
What's your question?
Yeah.
If
Yes.
the real answer is near 80, but we just took like, if we just said like 75%, like we
But
said
this is not an exam thing because you don't have this in the exam. I'm just trying to illustrate with the program the meaning of what we're saying in the graph. So if you had 1,000 numbers, how many did we say? About 750 or 75% should be less than 0.675. And I got 745. That's pretty good. It's pretty good. Now let's just do another one here that we calculated. So what one else did we calculate? Yeah, between -2 and 1, what did we get? 82%. So if I have 1,000 normally distributed numbers, how many should be between -2 and 1?
82%.
And 82% of 1,000?
820.
820. So let me see. What did I say? Between...
-2 and 1.
I wonder if I can type it in like this. I don't think I can, but I'll try. Between -2 and 1. No, that's KJ being a fool. Right, between... Okay, so between bigger than -2, and then also smaller than 1. KJ!
You're missing.
Please, leave me alone. Right, let me just get it here. Right, bigger than -2 but smaller than 1. Alright, so I got 813. I don't know why it's doing this business here. What did I say it should be?
820.
It's pretty close, quite close. Now, the reason we're looking at this is because like I said last time, when you drew your histogram, what shape was it? It was a bell shape. However, this average wasn't 0, right? Like, I mean, if you remember, or if you have it drawn, what was the average for the one you did for me? No, you're not even listening to me. The histogram you made yesterday, have you got it? Look at it. Tell me what the average was, or did you not calculate the average? The average is the point roughly in the middle of the histogram. What does that look like? I asked you to do question number 3, was it?
Yeah.
So, look at your histogram. Have you got it?
Yes.
What's the middle of it?
Is it the 0 point,
My goodness.
0.0375?
0.025.
No, there's no number on the axis.
Oh, this should be.
Around about 160. Yeah?
Yes.
You're talking about third one?
169.
Oh my goodness, what is the first histogram you drew for me? Open it up. Where's the first histogram you drew for me? Where's the histogram?
I'm confused.
Alright, fine, just give me the first histogram you drew. Did you draw a histogram?
This is the first one.
But you didn't draw it. So then you're no good to me.
Okay.
So, where's your first, did you draw a histogram? Yeah, so the average will be about here, in the middle. 169, 170, something like this,
Yeah.
okay?
165.
Is the average 0?
No.
No. But, with a trick in the class later today, we can change a histogram like this. Let me show you. Well, actually, you know what? I'll show you in the program here. I think will be better. So let's say we have our Z. And I'll make 1,000 points. And I'll draw the histogram for Z. And that's histogram of Z. Now let's make a different histogram. So, for example, let's do students' heights. So I'll call that, oh sorry, that's not the right histogram. This is not the histogram you want. This is the histogram you want. There's the histogram for Z. What's the average? 0. Yeah. Now let's make some data for student heights. What's the average student height, do you think? Roughly? 170. And the standard deviation, how far away do you feel students are from the average, on average?
5 to
No,
10.
20? No.
5 to 10.
How?
5 to 10.
5 to 10. So we'll say 10 centimeters. Yeah? And again, we'll make 1,000. So let's draw this histogram for H. Now they look very similar, don't they? There's the histogram for heights. There's the histogram for what's in the table book for Z. What is the difference? Is there much of a difference?
There's just a big difference.
I mean, this goes from 0 to -3 and 0 to 3. And then if I look at the heights, it goes from 170 to 140 and 170 to 200.
So 170 is like the 0.
Yeah, the 170 is like the 0. The height, look at the height. Please notice this density height. You see it? 0.03. Now if I go to the other one, what is the height? 0.3. Is it the same, isn't it?
No, 0.3.
Oh no, it's different. Did I make too many? Hang on, let me go back to my Z. I made 1,000, didn't I?
I don't know, I mean,
Doesn't matter. Doesn't matter anyways. Right, so anyways, my point being that if you look at the height one, this is like what is in the table book. But as you said, KJ, it's like the 170 average is 0. So what we'll do later today is we'll do kind of a transformation we will learn how to change what's in the table book to match any histogram we might have. And then this way we can use our table book to calculate the probabilities instead of having to shade it in and measure it on our histogram. No, don't pack up. You don't know that I'm finished. I know this sounds like the epilogue, okay? But there could be a plot twist, all right? Somebody could burst through the door and then we have an extra class. So just sit back, right? You don't know how this episode's going to end. Please.
Yeah.
Okay? Yes. So, remember yesterday we had to draw and shade and measure. It'd be much easier if we can change our histogram into a histogram in the table book, and then using the table book get a more accurate measure of the percentage, the proportion.
Is it always possible to change the
Histogram, as long as your histogram has a bell shape to it, it's possible. So, for example, if you look at the histograms of the last page as the answers, some of them, yeah, they look like a bell shape, especially like number 2 has a very clear bell shape. And even like number 4. But some questions like number 3, they have 2 peaks, so it wouldn't be very accurate to use this technique on that question. Now this topic is new. Last year the engineers did not do this, and previous years. This makes me feel like it's a guaranteed question on the exam because it's a new topic this year, and what's the point in putting it on the syllabus if you're not going to ask it? Like the probability. So you're pretty confident that you'll get a probability question on this or what you did in semester 1.
probability is coming out quite high?
I would put it at least 80% probability.
I'm counting on 20%.
See you tomorrow. No, see you later today.
Flash lost his powers. Flash lost his
Hang on,
powers.
hang on, I need a plot twist. I need to like take off my mask and then reveal that I am correct.